Hi, welcome to the Top 10 Azure Security Best Practices. My name is Mark Simos, Lead Cybersecurity Architect, and today we'll be talking about the most important things to do as you go through your Azure adoption and as you look to secure an existing Azure set of resources. So the first thing to keep in mind as we take a look at is really to take a look at the problem. What is it that we're trying to solve when we talk about securing Azure? So let's take a look at this through the criminal's point of view or for the attacker's point of view. And the easiest way to look at this and get a good sense of it is by looking at what those criminals, those attackers, sometimes nation state intelligence folks, what they can actually buy off of the dark webs, the bad neighborhoods on the internet. First of all, you can actually hire an attacker to do all the work for you. That costs anywhere from $250 is the cheapest that we see, all the way up. You can buy a ransomware kit, which is really designed for sort of those new criminals, those just getting started. And it costs about $60, $65 up front. But they also have affiliate models where they can take the ransomware kit author can take a portion of the proceeds of the ransomware attacks that the actual operator, the person, the customer of them uses. Compromised computers and mobile devices are actually fairly cheap. Less than $1 in most cases, quite less when you looked at the PC market. And the mobile devices tend to be a little bit more expensive, a little bit closer to $1 all the way up to $3 a piece, again, on average. And these numbers, just as a point of reference, have stayed fairly steady over the past 3-4 years that we've been tracking them closely. Spear phishing for hire to take over the account, payment upon, hey, I sent you an email from that account. That is the account and I am in control of it. Anywhere from $1,000 to $100 to $1,000 US dollars. And then we also have stolen passwords. These usually come from one or more breaches that have already happened, and they're about $1 per 1,000, a little bit cheaper in bulk. And those are essentially someone's username and password that have been used somewhere else. But because users people tend to use the same password over and over again, on average in any given enterprise organization, it's about a 1% hit rate for that username password to match within that environment. So actually pretty good odds for the attackers, fairly cheap. So we see a lot of password spray style of attacks. And then denial of service to keep a website down on a monthly basis costs a little bit less than $800 per month. So fairly inexpensive. And this is really the threat landscape, or one view of the threat landscape that organizations face as they're trying to keep their Azure resources secure and available and not tampered with. So as we look to what our customers needed in Azure and where do we need to invest to help keep our customers secure, this information led to a couple of different investment areas. The first there is native threat detection, including a native cloud-based SIEM, Azure Sentinel. But it wasn't just about having a place to do log analytics. We wanted to have what's the industry is coming to call XDR, detection response, the X being any detection response, which is very much based on EDR, endpoint detection response, started this whole trend. But those native threat detections that really have high quality alerts and response and investigation and remediation experiences. And so we've invested quite a bit to help secure all the different kinds of assets our organizations tend to find are under attacks. Azure, Azure AD, the identities there, Windows, Linux, iOS, Android, SaaS apps. So lots of investment there, even operational technology. Microsoft recently acquired a company named CyberX that does great monitoring of operational technology, so SCADA or ICS, for those computers that control physical machines and physical operations. Passwordless and multi-factor authentication is really where we focus on those identity and password-based attacks. Passwords, nobody enjoys them, admins don't enjoy them, users don't enjoy them. Actually, the attackers do technically, but we don't want them to. So passwordless is a big, big initiative at Microsoft because we want to get out of the business of passwords. We want to just look at the machine, have it do a facial read of a biometric or a fingerprint, or just the fact that you have your phone and your phone can do similar things. We want to get out of the business of passwords, investing heavily in there, as well as all the different forms of multi-factor authentication to support that and to secure where we are today. So the third area that we focused on is native firewalls and network security, because we found that customers, as they move to the cloud, they obviously need to bring network security capabilities with them, and they bring those requirements with them, but they often find that they want it to be simpler and easier like the rest of IT. And so we've invested deeply into native security capabilities within the Azure platform, including network security groups and a number of others we'll discuss a little bit more later. But also, we have a built-in native firewall so that you can protect the edge of your network, that internet ingress egress point, with essentially firewall as a service. And it's fairly simple and easy to configure. A lot less complexity, helps you get up and running with that security quicker. So this is one set of the things that we've invested in. The other thing that we've been focused on is really learning and then teaching our customers. So we've learned a lot from our customers. There's a lot of very sophisticated customers that we've learned from. We also work with NIST and the Open Group and many other experts in industry working together, because we want to build guidance for our customers, because we know the cloud is new. We'll be talking about that quite a bit, and so it takes a lot of education. But we also found that customers really want clear, prescriptive guidance that says exactly what to do. And so we've invested quite a bit into a number of different forms of that guidance. The top 10 best practices, which we'll be talking about today. We also have the Azure security benchmarks, which essentially are best practices and controls for security in Azure. What is the right way to apply industry best practices to Azure specifically, which is mapped to CIS and NIST and PCI and all these other common security frameworks that organizations align to. And then we know that the journey to the cloud itself can be pretty significant. And so Microsoft invested in the Cloud Adoption Framework, or CAF as we like to call it, to help people with that journey of going to the cloud. How do you do governance and cost and security and all these big picture elements? And so that's an area where we're continuing to invest so people can, organizations can have this smooth journey to the cloud. And then on a per workload basis, when it comes down to brass tacks and you actually have to architect and design a specific workload or application, we've also invested in the Azure Well-Architected Framework, WAF, not to be confused with Web Application Firewall, but that well-architected framework of what does a well-architected application look like. So that's efficient, it's secure, and all of the other attributes you're looking for in an application. And so a lot of guidance there, but today is about the top 10. So before we get in the top 10, we have a small announcement to make around the Azure Security Benchmarks, actually. So some of you may or may not be familiar with the Azure Security Compass, which is a set of guidance that was out there. What we've done is we've worked together as a team, quite a few hours actually over the past few months, to with the Azure Security Benchmarks team and the Azure Security Compass contributors, and we decided to actually bring all of those together into the Azure Security Benchmarks going forward. So the Azure Security Compass is being retired slowly. It's actually being migrated to Microsoft best practices, so that there's one set of Microsoft best practices across all of the different areas that people need guidance on. And specifically, the Azure Security Benchmarks are taking in a lot of those lessons learned from the Compass, and so there is now one place to go for Azure Security Best Practices, and that version 2 is out. And that includes not only the benchmarks themselves mapped to all these other industry best practices, and of course, Microsoft's take on them with the modern cloud, but also how do you apply those to individual Azure services? So SQL, Azure Functions, Azure Storage, the API Gateway. All of these different kinds of capabilities, how do you apply the benchmarks to those? And so that version 2 of Azure Security Benchmarks is out, and we're in the process of updating all of those services baselines that are associated with it. So on to the top 10. So these top 10 we view as essential cloud security in a way. And we wanted to make them as actionable as possible. We wanted to take a holistic view to look at the whole problem space. And we wanted to look at it from both the short term and long term. What are the quick wins I need to get today to make sure I don't get myself into trouble with an incident or an attack or something I should have known better? But we also want to make sure that they have a long view and that you're investing into things that that we're not overlooking those long-term things that are going to go ahead and come back and bite us. And so we broke this up into really 4 areas: people, because people, at the end of the day, are the center of any system. It's really about people enabling and empowering people, and particularly in security, often forgotten because it's been such a technical discipline, but ultimately you've got defenders and you've got attackers. And even though it seems like it's a technical attack, and it is, and there's automation, it is, there is a human there that is designing that automation, that is designing that malware, that is operating it in many cases in a targeted attack as an actual attack operator. And so we want to make sure we're focusing on the people, because there's also the equivalent on the defense side where people need to focus on making sure that people have the information they need, the context they need to be successful. And of course, there's a lot of things that you end up having to do over and over again, and you want to capture those in processes so that, we know who owns what, we know where that goes, we know what to do next, so that people have those things. And then the technology, which really automates as much of that process as it can to make things as easy as possible for people. So we're using those human minds, those great computers in our heads, to do the most effective and useful things instead of boring, repetitive drudge work. And then the last piece is something that we found is very interesting, because we're new at the cloud, and it's, we're starting to do things that we're going to be living with for the next 5, 10, 20 years, much like we were, 20 years ago when we started putting up Active Directory in Windows 2000 and setting those kind of LDAP directories up that didn't exist in the 90s. We're in that same kind of phase now with the cloud, and we want to make sure that when we pour this concrete, when we make those key long-term decisions, we don't want to have to go back and break it later, or just say, you know what, we're going to live with that. It was a bad decision, but we have no choice. It's too hard to change. So we want to get ahead of that and making sure we're setting these right foundational architecture decisions correctly. So let's go ahead and jump in. So one of the first things we realized is that it helps to take a step back and actually apply some perspective, because this is, as I mentioned earlier, a generational shift in technology and in computing. So we want to recognize that and understand that how we're doing our jobs today, we're going to be doing the same job. What we do isn't changing, but how we do it is going to change. So, the perfect analogy for this is moving from a house where you have to mow your lawn and feed it and fertilize it and take care of all those things and maintain all of that, to moving to a luxury apartment building with a great view of the ocean or the city or whatever you prefer, and that you're in a shared building, and that you're still going to have plumbing problems. You always will. That's just natural. You're still going to have electrical things, but you need to know, do I call my plumber when there's a problem here, or do I need to call my landlord and make them fix it? So you need to understand that sort of shared responsibility model of what do I have to do and what do I not have to do. There's a lot of things that actually get done for you in the cloud that you no longer have to do. Disk-based forensics is one of those things where the data sources are actually moving. So there's a number of places where that happen, but recognizing that how you do your job is different than what you're doing for your job. What is it that you're providing to your boss and to the organization in terms of value? And then taking a look, what is that what, and how do I apply it to this new world of the cloud? And so it's very important to take a look at it through that lens and recognize what you're doing is important. It just has to be done differently as you move to the cloud, especially as you're doing a hybrid over cloud and on-premises. So, starting with people. First thing to remember is that it is, as I mentioned earlier, really a system of people, because people are the ones making the decisions, they're the ones implementing the technology. If you want to go into it, people are also the ones that actually made the microchips and typed in every line of programming. And even if you do have a program that writes other programs, that one was originally written by a human. So we got to remember that it's a people-centric discipline, even though we work with technology every day. The way to think about what people need, quite frankly, is education and context as they move to the cloud is what we found. So think about it like you have a special operations team in the military context here. And these may be some of the brightest men and women. They're really good at their job. But if you drop them into a situation where they don't have any intelligence, they don't understand what's going on, who the bad guys are, who the good guys are, who they're trying to protect, they're probably going to do a better job than any random other person because they're training from the past, but they're not going to be doing it at their best. And so the things that you need to provide your really talented team that you have is they need education on the overall journey, the context, how things are changing. Things like what are the important cultural elements as you move to the cloud? Because we've built so many cultural assumptions around how on-premise technology works. We've got to look at those fresh. The threats themselves are changing. What are the things, the kinds of attacks that work and don't work? Shared responsibility. How does that shared responsibility work that I was discussing earlier? What is it that the cloud provider's job to do? What is it that it's my job to do? And what can I expect from them? What phone numbers do I have to call? What do I have to do to work successfully with them? And we invested quite a bit at Microsoft to provide training around all of that as part of our online documentation. So we'll be sending you links to each of these best practices and where to get that. So that's one of the big areas that we focused on because we know it's something our customers need. Now, the second piece is, okay, great, I've got the big picture, I've got the context, I know what's changing at a high level, but I need to do my job. I need to know where the logs are. I need to know where the storage is. I need to know how to do this. I need to know what tools I'm going to be looking at. How do I set permissions? Where's the firewalls? So we know that organizations, people and professionals need that specific training on it as well. And so we've got quite a few resources on that we've collected together at Microsoft to make it as easy as possible for folks to learn exactly how the cloud works and exactly how to do very specific tasks. So best practice 2 is really around educating on that cloud technology, how it works, and we've got all that published so you can find that very quickly as you're ramping yourself up or having your team ramp up. Moving on to process. So the first thing that we've noticed in the process space is that if nobody owns the decision, is nobody's accountable for making a decision, the decision isn't going to get made. And then the project to go to the cloud isn't going to go forward. The business isn't going to realize value. The IT teams aren't going to be seen as successful. And the security teams aren't going to be able to secure it because nobody knows who's making, in this case, the security decisions of going to the cloud. So that's one of the first things we found is it's so critical to figure out who's making what kinds of security decisions. So we published very clear guidance on, I think it's 5 or 6 categories of exactly which decisions need to be made, which types of decisions, and which teams that we find within the customer typically are the ones that actually make these decisions, because we found that helps clear obstacles and make the project not only go faster, but be a lot more secure, because you don't end up having the project getting frustrated that security isn't moving forward and then just bypassing them. So it's very important to get those security decision-making assignments made as quickly as possible. Next one is really around incident response. You don't want to have to plan for a crisis during a crisis. So we found security incidents happen. We have a principle of assumed breach or assumed compromise because it happens. Attackers are constantly doing their thing. It's fairly cheap. There's really good return on investment for the attackers. So they will be constantly attacking. And as you move to the cloud, the attackers will continue attacking you there. So it's important that you have that preparation, some of which is the education we mentioned earlier, but some of which is updating the processes. So if we get this kind of attack, how do I do host-based investigation? What is the process for this? Who is responsible for it? Who's going to do these pieces? What kind of training do they need? And what tools do they need, etc. And so we found that updating your incident response processes really helps as you move to the cloud. And it's very important to focus on that as early as you can. Last one, posture management. So in the process space, there's something new in the cloud that hasn't been possible before. Security industries talked for a long time about continuous monitoring. We want to have a continuous view of where our security posture is and what kind of attacks are happening so we can make real-time decisions. Well, along comes the cloud, and guess what? You got your wish. Now what? And so the challenge that we see organizations face is they're not quite sure who is responsible for fixing this with this real-time data that's coming in. Who's responsible for monitoring it? So Microsoft, based on our interactions with different customers and others, we've put together a set of recommendations on, using Secure Score. Who is the one that's monitoring the Secure Score and the other security posture pieces? Who's making sure that they're holding everyone else accountable to remediate it? And then who is actually fixing it? Who are the ones that are responsible? Hey, we found that SQL needs this configuration change. We found that there needs a patch that needs to be applied to these VMs. Who is going to actually do that? Who's going to apply it? And simple theme is as close to the resource owner as we can get. So those decisions should be made by the same people that are accountable for the risk of that not being available, right? So the people that own those resources, the application owners, or say the storage and database owners, really depends on your model, how much you're doing DevOps and how much you're doing kind of specialization. But ultimately, whoever owns the resources should be responsible for also securing them and actually honestly held accountable for it. And then you have another group, usually a governance style group, that should be doing the monitoring to make sure that we're moving forward in our security posture and not moving backwards. This is particularly important in the cloud because of how fast things change. Not only are new features coming out all the time, but resources are being created and modified and removed all the time by these teams that are doing it because they need to keep up and they need to keep their organization agile. And so with all this change, it's super important to have very good clarity on who is monitoring and then who is remediating all these. And we built in a lot of automation in Azure Security Center and Secure Score and other capabilities to make this as easy as possible. And now we get to technology. So technology, the first one, and this is extremely important, is passwordless or MFA. In most cases, you have to use some form of multi-factor authentication as a stepping stone to passwordless, because passwordless is something that is possible, but it's not perfectly applicable and universally easy for every single scenario. I personally haven't used my own password in a very long time, usually 2 to 3 months, sometimes 6 or 8 months between actual uses of the password, and frequently it's when I get a new computer. Because I use the Windows Hello biometrics, easy to log in, looks at my face, allows me in, and it's much stronger than a password ever was or ever will be. So passwordless is very possible in a number of scenarios, but it's not 100% applicable in all cases. But at a minimum, multi-factor authentication especially for admins, but really for all users, start with the admin's role to every users. Very, very important here. The great thing is that it's actually easier than remembering and typing a password. So very, very strongly recommend that. Super important. So the next one, number 7, native network security and firewall. We've learned that organizations are looking for more simplicity. Sometimes simplicity comes in the form of using, hey, I have an existing familiar capability, a checkpoint, a Palo Alto, or some other next-gen firewall. Great. So we've got that. It's in the marketplace, and we can do that. We're also seeing organizations demand a different kind of simplicity, that they actually want to have firewall as a service. I want something simple. I want something easy. I just want something built in where I just click, and I'm done. I don't want to have to set up load balancers and virtual appliances. So we offer that choice in Azure, and we focused on building more and more capabilities into Azure Firewall, which is our native firewall as a service and allows you to do things. So we'll be showing that in the demo in just a few minutes. But that native network security and firewall, in addition, it's more than just firewall. There's network security groups, web application firewalls. There's quite a few different capabilities in there. But we found that organizations increasingly want more and more built into the platform, so it's all manageable in one way and it's as simple as possible. Because we've learned that complexity, quite frankly, is often the enemy of security. Because if no one can understand it, then it really ends up getting in people's ways, or it's not as secure as we think it is because nobody, quite frankly, understands it. Similarly, we're seeing some of the same things in the native threat detection. And now the native threat detection is also important for an additional reason other than just it's built into the platform. We found that it's very difficult as all these new types of capabilities, IoT devices, and some of the older ones, the OT devices as well, Kubernetes and containers, and all these different kinds of new objects are really challenging for vendors to keep up with because the cloud moves so fast. And so increasingly we see organizations demanding, I just want threat detection built into Azure. I want it easy. I want to be able to click a box, and I want the storage accounts to just send those alerts right on up. I want the SQL to send the alerts right on up. I just want them all in one console, and I want to instrument all of the different stuff, all the different assets that I have into that one place. And so Microsoft is investing very aggressively into native threat detection. So not only do we have the Azure Sentinel, which is a SIEM to pull all these sources together, we also have Azure Defender, and all of the different resources that are either in Azure or connecting to Azure have that first-party threat detection capability in there, so you can get a high-quality alert that you don't have to waste time trying to write a SIEM rule on. You have detection, and you also have the response capabilities to help with investigation so that you can make it easier as the analysts are dealing with a live investigation to make it as easy as possible for them to get the data they need and query it and dig deeper. So let's go ahead and move on and actually take a look at how some of these native controls work. This demo, I'm going to give a quick overview, and then I'm going to actually do the demo. We're going to show some of the native threat detection capabilities, as I just mentioned, and what those alerts look like and where they come from. And then we're also going to take a look through the native security and governance capabilities. So Azure Security Center, Secure Score, and those capabilities for that big picture view from a risk perspective, not just the threat perspective, sort of the what could happen as opposed to the what is happening. Then we're going to take a quick look at the firewall and how that's configured, as well as Firewall Manager. The web application firewalls show you a sense of what that looks like, SQL protection, and a few other security features, just to get a sense of where this native security is and where you can find it, and a little bit about how to configure it. All right, so we've got our demo up now. And we're going to take a very quick tour through a lot of these security features and capabilities that are built into the Azure platform, these native capabilities, just to give you kind of a sense of where they are and where to look. We're going to be going through quite a few, so not going to go through all of them in a lot of depth, but just want to give a quick sense of what's there so that you're familiar with where to look for those in the platform. So we're starting here in Azure Security Center. It's a fairly easy place to find. Actually, if you're on the home screen of Azure, there is that little green shield icon there to find that. And so, as of Ignite, we now have two different names for what used to be known as Azure Security Center. The first is still Azure Security Center for sort of the secure score, hygiene, compliance, and those capabilities. But all of the things that formerly were known as Azure Security Center Standard are now known as Azure Defender. And that's part of what we are calling our XDR strategy. Started with EDR, endpoint detection and response. It's now X for any detection response. And so tools that are specialized to a platform to provide those threat detection, threat response, and related features. And so Azure Defender is right there up front in Security Center still, which is where it originated. And so we're going to take a look first at the Azure Secure Score elements of it. And for those of you that aren't familiar, this capability is really designed to help you plan and figure out what to do. The top 10 are a great way to get started, but you're going to want detailed guidance and detailed actionability of specifically what to address. And so that's where Secure Score comes in and gives you a nice rating and ranking of how you're doing versus your peers, etc. So we can go ahead and click into Secure Score here, see what the score is in this particular environment. And then if you have multiple subscriptions, you will be able to see all those there. You'll also be able to see which subscriptions you don't have visibility into so that you can go and work with those subscription owners to get those. And this covers a whole lot of things. You can see which ones give you the most points. And the remediate vulnerabilities, no surprise here. You will see that multi-factor authentication is one of the higher ones. I'm sorry, that's actually its own one. That's individually one of the highest ones. In this case, this one's good. That's the largest amount of points typically there. And then in this case, this particular demo tenant here has a number of different things. And you'll notice that some of these have a quick fix button to them. So the ones that we could automate, remember we're trying to simplify and automate folks' jobs, there is a quick fix button. This is typically done by the people that are responsible for the resources to remediate them, as opposed to the governance function that's kind of looking at the all-up report. But we did want to make it as easy as possible for folks so that they could fix these issues as fast as possible and lower your attack surface and vulnerability. So now let's go back to the main screen here, and you'll notice that there's also a lot of compliance capabilities. So we know a lot of organizations have to meet regulatory requirements, and so we have built in the ability and mapped in all of these similar types of controls to all these different compliance regimes or compliance requirements. And it details out, there's some things you can detect technically, there's some things you can't. And so all the ones that we can detect, we do mark there whether it's being met, with a nice green checkbox there, and whether they're not. And then the ones that are grayed out are the ones that are actually are not able to be measured either at this time or at all with the platform. And so quite a bit of coverage here: Azure CIS, PCI DSS. We have our own Azure Security Benchmark, which just got updated, HIPAA, high trust, and the like. So we do take customer feedback on which ones to address first and focus on. And then let's go back to the Security Center home for a moment and take a look through the Secure Score itself. I'm sorry, not the Secure Score itself. I get confused. We can take a look at the different recommendations that are being made here. And if we look for Linux, you'll notice that there's a whole lot of recommendations here specific to Linux. You look for Kubernetes, because say that's your responsibility, is that you have to handle the container security and the orchestration security. You can search for those and find those. Same thing is true of SQL and IoT and a bunch of other technologies. So it's a pretty quick way for someone that's only responsible for those to focus on what they can do to improve the organization's secure score. So let's switch over to Azure Defender now to give you a quick sense of that. And so we can take a look here and get a nice summary of how well we're doing from a coverage perspective. Do we have good coverage? And notice here in this inventory piece, we can also notice where we have healthy and unhealthy agents, so we have visibility. Again, building on this software-defined data center, because everything is software-defined, it's all instrumented, and we have good visibility into it to say, hey, we're not going to be surprised that we lost, or more often found, some old Windows 2003 or Solaris box or something like that in a physical data center, because everything in here is an object, it's managed, it's defined. So it's fairly easy and straightforward to pick that up. So if you look in the Azure Defender piece, you'll notice again that coverage across Kubernetes, app services, Key Vault, SQL, you name it, IoT, and also with our new acquisition, very soon you will see legacy operational technology, so SCADA, ICS types of devices, from the 1990s, 1980s, and sometimes before. So we've got coverage for that coming in here as well. So the Azure Defender for IoT will actually include not just the modern IoT, but the old stuff. And so you can see where you're going on there. What are the top threats, the attacks that are happening, the alerts that are affecting the most resources. So lots and lots of insights here. Don't have time to go into all of those, but all the things you're familiar with, if you're using Azure Security Center Standard, are here. The adaptive app control, just-in-time access to VMs for the management ports and whatnot. So lots to explore there, lots to learn. So the next thing we're going to do is we're going to switch out of Azure Security Center and Azure Defender and into Azure Firewall to have a quick sense of that. So we can take a look at the Azure Firewall here. We do have a test firewall, so we're going to take a look at that. And the nice thing about this is, because it is firewall as a service, you don't have a lot of load balancing and similar kind of configuration setups and routing to do. You simply just connect that firewall to a particular virtual network, and then what is the public IP, if any, that this is associated with, and then you're off to the races. And then it's essentially acting as a firewall. There's obviously the activity log. There's the access control to who can manage this particular firewall. There's tags, so you can keep track of them if you have different firewalls for different business purposes or different layers or tiers within your environment. Working on some DNS elements there. And then you'll notice that there's a threat intelligence tab. And so within the threat intelligence piece, we have 8 trillion signals a day coming into Microsoft. And so we have a lot of rich context on what's going out on the internet in terms of which identities are bad, which IP is bad, or which DNS are bad. Now, a firewall only can really apply a bad DNS address or a bad IP address that are known to be malicious. And so you can actually just simply turn the alerts or the alert and deny on, and that's really all you have to do to take that huge amount of threat intelligence that's been essentially processed down for you there. Go into Firewall Manager. And so there's an interesting, most folks are familiar with VNets or virtual networks that are a collection of subnets effectively, where it can be broken down into subnets. You can look at it either way. A firewall manager really takes advantage and is kind of a reflection of the maturing of how we've gone from those VNets up. Because the VNets are just a basic virtual network. And then we realized as people peer-to-peer connected that with VNet peering, it got complicated. It got difficult to kind of track and understand and set an enterprise policy on. And so we created this Azure Virtual WAN concept, and then that allowed us to do a hierarchy. And then when we wanted to add firewalls in there, Microsoft, we also do support third-party partner firewalls as well. Then we created this concept called virtual hubs, which allow us to essentially make it very easy to manage the connections and the routing between those, as well as the routing through the firewalls, either the Azure built-in firewall and a number of actually partner firewalls as well. So that's really what the secured virtual hubs does. And of course, as Firewall Manager implies, we can also do the firewall policies and manage those centrally, and set up those Azure firewall policies and configure them. Now, firewalls are great for sort of unsolicited inbound traffic, but we also want to make sure that we are addressing the WAF scenario, which is traffic that's targeted at your application and intended to be malicious to try and exploit that application. And so we have web application firewalls built in as well. And so we'll go ahead and create a policy here to give you a quick sense of what that looks like. And we'll just say, in this case, an application gateway. It does link to the front door, the application gateway, or the CDN, content delivery network. So you have those options there where you're going to put the WAF. And then, let's pick a resource group. Demo is just fine because we're not going to actually create this. And then we'll just call this test WAF. And, the policy settings themselves, you can put some exceptions in there, etc. And then, prevention or detection, of course. Manage rules, OWASP 3.0, 3.1, we support those. Custom rules, if you do have learnings on your specific app that you want to have, and or you want to tailor over time, as opposed to these. And there's quite a few built-in rules for all the different, in this case, OWASP best practices and the specific rules that support those. So quite a bit of capability there in the web application firewall. And then in all of the different Azure services, there are varying different types of security capabilities. We're going to take a look at SQL today, but there's quite a bit in storage as well. So if you take a look at the SQL databases, we'll just go ahead and jump into one of these here. And you'll see here that you have, as you look at this database, quite a bit of security context information. The SQL team has done a great job of pulling through, how are you doing on your transparent data encryption, your Azure Defender for SQL, your auditing, and really kind of pulling some of those things. This is the SQL interface. This isn't the SQL security interface. This is the SQL interface. So they've done a great job of exposing security very naturally through there. And so this one is one of the is a great example of kind of how we do stuff. And there's a couple other features that I want to cover very quickly. Some of these services, all of them offer and support what's known as private link, which allows you, I'm sorry, not all services, but all of them will do this. We're going through every single service and making sure they all support what's called private link. And so when you do that, you can set up a private endpoint on each of these different services instead of having your instance of SQL, your instance of functions, your instance of Kubernetes or whatever it is exposed through the public networks and the public internet, really the Azure networks. We actually are putting the option in that all of them will be able to project onto a private network. And so instead of being exposed through a public IP address, it will only be exposed through your internal private IPs. And then you would publish through the normal sort of WAF application gateway pieces. And so that's coming for nearly all the services. We're making really solid progress on getting the 3,400, I can't remember the number, Azure services set up for that. But a few of them also, including SQL, additionally have the ability to set specific network filtering rules, often called a server firewall or firewall settings, for that specific service. So you will see that in there as well. And so you can then go ahead and block and allow addresses in there. So that's another one of the capabilities that is there. And the other thing, and this is the reason I picked SQL to show the demo on as opposed to storage or the others, is there's something else going on. So some of you may have heard of Microsoft Information Protection, which is our vision for really having a single set of policies that you can do classifying, labeling, protection of all types of data, structured, unstructured, you name it. And so we've gotten very, very strong capabilities in the unstructured, the document space, and we're starting to see those features, and we're investing here and continuing to invest in the structured space. So in SQL, we do have data classification as well. And so let's take a look here in the data discovery and classification. We're not at the point where we can, based on the classification labeling, actually protect the different cells and rows, et cetera, differently, but we're on that journey and we're moving in that direction. And so you'll see here that you can, using very similar identical policies actually as your Azure Information Protection for documents, you can set those same sets of policies and labels up in SQL. And so we can label those and then make sure that we then set up the appropriate transparent data encryption or other types of protections within SQL. There's a lot to SQL. I don't have time to cover them all, but wanted to give you a sense of that because this is a sign of things to come. We're investing very heavily because we want customers to have this single set of things, and then you can apply it to any types of data. So with that, we've covered quite a few of the different technologies, and so now we'll get back and close out on the best practices. Now that we've gone through the demo, we're going to talk a little bit about long-term. So we're going to talk about the way I like to think about this, and this is the reason why we have kind of the bricks and mortar kind of concrete icon there, is if you pour the foundations wrong when you're building a house or a building, it's really, really hard to change later. And there's a couple of decisions as you build your architecture in Azure and any other cloud that if you get them wrong, you pretty much have to break the concrete and spend a lot of time and effort kind of changing those foundational underpinnings. So we really want to get those foundations right the first time because it's no fun to try and fix them later. Those are ugly projects. So number 9 here, single directory and identity. We know that enterprise organizations have a lot of different directories in many cases, or different identity management systems. It's a very common configuration, especially among medium and larger size enterprises. For the cloud and going forward, we strongly recommend you want to get to a single directory and a single identity for each user, for each person. There's one minor exception to that, which is admins. Administrators with high privilege access should not be using their day-to-day use account with their for doing administrative tasks. Those two should be separated because there is a security risk of merging those two. But for every other user in the organization, including the admin's day-to-day account, you want to have a single directory, so there's an account in one place. And Azure Active Directory and Active Directory essentially act as one directory at this point in time. That's evolved quite a bit over the years. And so you want to have that single directory, and you want to have a single identity, because when you look at this from everybody's perspective, the end user trying to remember different passwords, different accounts, different usernames, very painful. You look at the admins that have to administer different directories and slightly similar things and all the connections you have to have between them, it gets very complicated quickly. And then you look at the SOC analysts and the people that are supporting the SIM and the other analytical pieces to correlate all of the security stuff happening. When you have multiple identities, you have to integrate even more systems into this and then figure out how to correlate between, well, that happened on this LDAP directory, but this was on the enterprise one, and this is our customer database. And are these the same actual John Smith? It gets really complicated really fast. So we've learned, at least from the now going forward, make sure you're standardizing on a single directory. So pick one enterprise Active Directory tenant, and that is the enterprise going forward. For most organizations, this is the Active Directory tenant when you went to Azure, when you went to Office 365, because it's the same Active Directory that underpins Office 365 as all of the other Azure services. And again, like I said, we've really extended Active Directory on-prem to Azure Active Directory and made it as if it's one single system where you make a modification one side and it will sync in either way depending on your configuration. So we want you to have that single directory, single identity. It makes everybody's life easier in security, in IT, all your end users. It's a victory in all corners. So get this foundational decision right. Don't be trying to layer on virtual directories and extra things. Just use one if you can. Number 10, identity access instead of keys. we have learned you can't be 100% perfect on this. You can't always use an Azure AD account instead of a key, like a shared access signature or an access key. Because the cloud initially, the first early versions of it, both Amazon, ourselves, GCP, and whatnot, the cloud started doing authentication heavily using keys instead of identities. And for those of you that haven't done key management, it's painful. For those of you that are doing key management, I'm sorry, it's painful. Key management is not fun. Now, you can't be 100% off of key management. There's always a case where you may need to do that. There's always particular applications, legacy architectures, certain ways things have been done where you actually have to do keys. But where there is a choice, and Microsoft is pushing very heavily on our internal engineering teams to make sure that every single Azure service will be able to use Azure AD for authentication. Again, back to that single directory, single identity in 9. In all those cases, in all of the Azure services, we will support Azure Active Directory. That is a path we are on. We are working very hard to make that 100% across every service. We recognize that there are still gaps now. We recognize there are certain applications that require using and managing a key. We get that. But in every place that you have a choice of using in a managed identity, use it instead of a key. I like to think of key management as being similar to handling raw nuclear material. It's possible, but it's not fun and it's not safe. It's really easy to make a mistake. You want to have something that's packaged up nicely and that has its lifecycle management, which is what an identity does. Identities are very much key-based under the hood, but you manage them in a nice directory. They've got a lifecycle. They've got a password reset process. They've got all these different things to make managing it easier. So avoid keys everywhere you can, because you don't want to be educating developers on how to handle a key well. You'd rather just say, use this identity and let our identity admins deal with it. Much, much better process. So everywhere you can, avoid using keys, use identities. And then last, this is kind of the special bonus, there's actually 11 best practices. Sorry, couldn't contain ourselves, couldn't help it. So 11, yes, 11 of 10. Little special bonus, no extra charge. So single strategy. So I'm going to start with a story on this one. If you go to any sort of enterprise organization, you ask the networking team, tell me about your enterprise segmentation strategy. They're going to tell you about IP addresses and ranges and CIDRs and all sorts of things. And is it a /24 / whatever? And go through all that kind of stuff. And it's going to be very much based on sites and physical networks and whatnot. Then you go to the identity team, and they're going to talk to you about OU structures in many cases and groups and how those things are set up. And then you go to the application team and you ask them the same question. And they say, we don't really use those much. We kind of do, but not really. And by the way, the application teams are the ones that actually talk to the business and to the business stakeholders. And so you end up with what I like to call a misaligned cheeseburger, where you have all these different teams that are trying to do roughly the same thing, but they're not talking to each other and they're not sharing, they're not aligning, they're not actually coordinating well. And so you end up with a situation where the defenders are really at a disadvantage and the attackers have all sorts of extra opportunities because of this lack of coordination between the teams. And of course, there's also all sorts of organizational friction. And so even though, I use this example of an enterprise segmentation strategy, but there's so many more decisions, whereas if your teams are not working together, they're not coordinating, and you don't have the networking folks and the identity folks and the application team and the productivity team all working together to figure this out, that you're going to have these challenges. You're going to have a lot of friction, you're going to have a lot of gaps. And we have learned as we work with our customers and we go and we do architecture design sessions and have these conversations, if we don't have everyone in the same room as we're making these strategic decisions, we're going to keep repeating that meeting over and over again. Oh, we didn't have the networking team in the room, and we didn't have these guys, and we didn't have the identity team in the room. Well, then you're going to have the same set of meetings all over again until you have everyone there, because everybody has to understand this new world. They all have to make decisions together, because the silos that we built over the past 20 plus years in enterprise IT on premises aren't necessarily the way things should be divided up as you move to the cloud. There's some subtle differences. And so everybody has to realign and reorient around this new world and figure out, okay, what does your team do? What does my team do? What does this team do? What does that team do? Understand who makes the decisions and move forward. So it's very important to build a single strategy together as an entire organization. And really, it's time to start, connecting those silos and working forward. So some of you may have seen some of my sessions before, and you may be thinking to yourself, wait a second, this is a Mark Simos talk, and all of the slides have been very simple and clean. There's been no really big complicated diagrams. Is that really Mark Simos? Well, for those of you that are looking forward to that, we do have a special treat for you. There is a big complicated slide that brings a lot of concepts together. So this is really targeted at sort of those security professionals, IT professionals among you that are trying to pull all this together. So these best practices are great, but tell me how all this really works. Give me the specific features and technology names and how do these things connect with the arrows. And so what we did was we put together this diagram that really describes how this native security for Azure works. Keep in mind, we love our partners. We love the existing capabilities our customers have. We want them to be successful with it. This is representing the Microsoft capabilities because, quite frankly, we ran out of room to include everybody. And there's a lot of partner integration here that is not necessarily depicted, but we wanted to show all of these native capabilities and how they come together. So that middle black bar there is really showing sort of the end-to-end life cycle of Azure and all things related to Azure and the security of it. We've learned that teams need two things to be successful in security. The first is visibility. The second is control. You have visibility into both the risk factors and governance things and the overall how are we doing and are we vulnerable, as well as the threat detection, which is high quality alerts, as well as the raw data and logs and signal to be able to do something with that. The control side has that same governance need. You need to be able to sort of set up policy and guide developer teams and IT teams and whatnot. But we also need preventive controls to block the attack. So if we can block an attack, it's a lot cheaper. It's a lot more effective. You can't always block an attack. Often you have to detect it because the things that an attacker can do are so broad you can't block everything. You couldn't possibly block everything. So you have this flow. And the first thing everybody asks us in the security team is, where are the logs? I want logs. Give me logs. Of course, we provide the logs. All the Azure services through Azure Monitor and whatnot, we provide all those different logs. And we've learned that there's something that organizations and security people aren't used to asking for. And this kind of goes into what I was discussing at the beginning, which is alerts. Organizations need, but aren't used to asking for high quality alerts. I want a high quality alert on my IoT and my legacy OT, my legacy operational technology. I want high quality alerts on my containers, on my SQL, on my storage accounts, from my VMs. I don't want to have to write a SIM rule. Everybody's used to writing a SIM rule, a SIM query, and do their static analysis. Everybody's used to that. They're not used to getting high quality alerts that are ready to go. I can investigate this. I need to investigate it now. They're used to just getting raw data. And so we focus very much on providing not only that raw data, but also those high quality alerts. One of the things we've learned is that protecting Azure is not just about protecting the stuff that's literally on Azure. If you lose control over the account that is an administrator of Azure, or the workstation where that account logs in that is an administrator of Azure, you also lose control over your Azure tenant and the resources in it because the attacker can impersonate those accounts either by taking over it from the machine or just taking over the account directly, password theft and whatnot. So we've learned it's important to have that full end-to-end view. Now this is an Azure presentation, so we're not going to go over it in too much depth, but when you look at the whole picture, Microsoft has also put a lot of investment into that front end. So taking those same high quality alerts on the endpoints and the identities, etc., feeding those into the preventive controls and into the endpoint management so you can make better decisions and you can make real-time access decisions through conditional access and all these other kind of pieces. Essentially providing that zero trust access control there in that kind of T-shaped box, the upside down T. So that is very much part of Azure security as well, but we're going to spend more time focusing on the right today. So when most people think about how do I protect stuff, they think in the paradigm of what we were able to do in the on-premise world. And we call that data plane security. And this is very much focused on per application and per workload controls and protections. So this includes things like firewalls. Even though we're quote unquote protecting the network with a firewall, we're actually protecting the workloads that are on our network or that are in our environment. It's things like encryption and using Key Vault to manage those keys for the ones that you do have to have. It's about following DevSecOps and securing your code. It's about, and just application security in general. It's about securing the API access, securing the network, so that you're securing assets against network-based attacks, DDoS protections, web app firewall to protect the applications. So all of these are really about protecting the application, either in aggregate as a whole at that network edge or on the specific applications themselves. So this is kind of the classic security piece. Microsoft has invested quite a bit to make sure all of those things are there in a cloud-native format so that you can use them to secure it. The thing that's new and interesting and different about the cloud is we're no longer sitting inside of a dumb building. We're not in a building where you badge in and that's how you get access to, putting a server into a 19-inch rack or blades or VMs or whatever else you have in your physical data center. We actually have a software-defined data center. And that, because it's software-defined, it can be intelligent. And so Microsoft, we took advantage of this fact. So everything that's created in Azure or updated or destroyed, all the resources in it, go through the Azure Resource Manager, or ARM, as we like to call it. And so because it's software defined, we can intercept all of those requests, all of those changes, all those creations, all those deletions, and we can apply policy where you can set up and say, if this thing happens, you always add a firewall. If this doesn't have a firewall, you block it from being created, or whatever the case may be. There's a lot of different scenarios in this, but you have policy control that's built into the data center itself. That's what we call management plane security in that darker green box. And so, plenty to read up on and research there, but we invested a lot into that to take advantage of that and really have an intelligent software-defined data center, not just a simple dumb platform. We wanted to have something that was actually taking advantage of the data streams that we have, the intercept we have to apply policy, and really help make the platform a lot more secure. Very top there on the right, Azure Cloud Adoption Framework, I mentioned earlier, really about going to the cloud securely. We're investing more and more and putting more and more security guidance in there. There's quite a bit already on security roles, responsibilities, and whatnot, and strategies, and then we're continuing to develop that as well. And then in the middle there, the Azure Security benchmarks, that gray box, is, like I mentioned before, those prescriptive best practices and the controls, and lots of investment there so that throughout all of this you have those best practices that you can use to apply, when to apply these and how to fit in your existing third-party capabilities, and what do you do to configure it so that you're not vulnerable to those attacks. So as we wrap up here, and in case it wasn't clear before, we want you to follow these best practices. We want you to go to that Azure Security Top 10 link there on the top right. We've also provided convenient links to each specific one so you can dig into that. We've provided a lot more detail on exactly what we mean and the resources available, the videos, the documentation, feature capabilities, you name it. So all of that is linked in each of these to make it as easy as possible for you to follow these best practices. So please continue to read up on the Azure Security Top 10. Starting with the people side, cloud security journey. People need to know the context of the journey they're on. Technical training, they need to understand the specific components they're going to be responsible for. People in IT are really good at learning technology as they go. The cloud is a lot to learn quickly. So keep that in mind. As much as you can provide them training, documentation, guidance, the better. We've provided a number of resources there. But as much as possible, provide people as much training, because it gets very difficult to learn hundreds of things at once or tens of things at once. One or two things at once, not so hard. But when you get a lot, it's overwhelming. Assign accountability. Make sure that you know who's making what security decisions. Make sure you're updating your incident response process. Posture management, you have the data, you have the dashboards, you have the information. It's all part of the free part of Azure Security Center. Use it, take advantage of it. Passwordless and MFA. I think the statistic, if I recall correctly, is 99.9% of identity attacks, not all attacks, would have been blocked with MFA. The attackers don't even have to try. They don't even have to invest to get around MFA. So get your admins on MFA, make them work for it, make them earn it. Native network security and firewall, take a look at the stuff that's built into the system and see if it's got what you need, or see if you are going to bring your existing firewall and capabilities with you. Very important there. Native threat detection, take a look at the stuff we have in the platform. There's an amazing set of threat detection capabilities, some of which we took a look at today, to help make your life easier so you don't have to pull a bunch of logs in the SIM and then try and figure something out. So great capabilities there. Foundational decisions, single directory, single identity, make life simple. Separate accounts for admins, but for all other things, single directory, single identity. Identity access controls, use them instead of keys. Avoid key management if you can. If you have to, use Azure Key Vault or something similar, but avoid keys if you can. And lastly, get everybody on the same page. Single strategy. Get the teams working together. Use the enterprise segmentation strategy as a way to get everyone on the same page. Use the move to Azure and the need to make these decisions up front as a way to get all the teams in the same room. You'll be amazed at how many connections happen, how many good conversations happen, and how many good things start up as people start working together instead of working in their individual silos. And with that, I thank you very much for watching. Stay safe out there. Thank you.